My name is Audrey Nasar. I'm a math professor at the Fashion Institute of Technology in New York City, as well as an illustrator. And I'm going to talk about symmetry cards, which are a deck of cards that could be used to teach or to introduce symmetry groups. So FIT is a fashion school, but it's really more of an art school. And I teach math courses that relate to my students' fields of study, which include illustration, animation, fine arts, graphic design, and fashion design, among other things. In particular, I teach a course called Geometry and the Art of Design, and in this course we cover symmetry groups. So I created these cards to teach specifically rosette symmetry groups, which I'll give a brief overview of for those who may not be familiar with them. The two types of symmetries in rosettes, which are finite figures, are rotation symmetry and reflection symmetry. You could see on the left, the Z is being rotated 180 degrees, and it looks the same. So that has rotation symmetry of order 2. And the A is being reflected along this vertical reflection line. So that has one reflection line. It also has rotational symmetry of order 1 because it can be rotated 360 degrees and look the same. That's true for all finite figures. And so using these symmetries, we can divide rosettes into two symmetry groups, cyclic, which are shapes with rotation symmetry only, and then dihedral, which are shapes with both rotation and reflection symmetries. If you notice on the left, these are what the cards look like. And so specifically on the left, you have a character interacting with an everyday object, in this case a flat tire, and so I guess I hope that's not an everyday object, but in the corners, you see the hubcap repeated, and that's what we're going to be classifying according to its symmetry group. It has order of rotation of 5, and so that would be considered a C5. On the right, the bone that's supposed to be thrown here is dihedral. It has both two reflection lines, the horizontal and vertical, as well as rotation of order 2. So that's a D2. And in both notations, the N denotes the number of rotation symmetries, but specifically with dihedral, that's also equal to the number of reflection lines. So the deck is made up of 52 cards and 2 wild cards. It's divided into 4 colors, red, blue, orange, and yellow. There are 13 ranks per color, and those correspond to the symmetry groups, C1 to C6, D1 to D6, and D infinity. So you'll notice the structure is identical to a standard deck of playing cards, which means that you can use the cards to play any game that you would play with a standard deck. However, I have 2 games to introduce, maybe just one, and I'll leave the other as a teaser. And these will be specifically to teach symmetry. So you could do a basic memory game where you would turn the cards over and you look for pairs. In this case, what makes a pair is if the figure in the corners has the same or falls in the same symmetry group. So this is an example of a match, specifically a D1, because both of those shapes, the butterfly and the upright base, have one reflection line as well as one rotation, which is that 360-degree rotation. So now's your turn. You've got 4 cards down below, and you've got the card up on the right. And can you tell which one would be a match? So if you said the petals, that's correct. They're both C2 in that they have rotational symmetry of order 2 and no reflection lines. And let's try one more. Hopefully you said the radioactive symbol, which is correct. That's a D3, and that means that they both have 3 reflection lines as well as rotational symmetry of order 3. Okay, and I'll just give a sneak preview to the other game. This is my favorite, and you'll come see me at the table if you want to play. And that's an example, which we won't get to. So next steps, I just printed the 3rd edition. I already have an edit, so there'll hopefully be a 4th. And you can come get a copy at the sales table. If you have more questions, just ask. Thank you.